everyone. Now we are going to discuss about physical thermodynamics. Physical thermodynamics. What is meant by thermodynamics? In chemistry, we studied thermodynamics was the study related to heat and its applications, right? In physics, thermodynamics means the same thing, but we are mostly dealing with engines. Okay, so physical thermodynamics, we are mainly dealing with physical side of that. That is mainly the topics related to heat engines, okay, and various other laws of thermodynamics. Understanding thermodynamics, we have to understand various laws. Laws of thermodynamics. Laws of thermodynamics. What are the different laws regarding the topic thermodynamics? The whole universe works on the principle of the laws of thermodynamics. So what is the fact behind that? Before understanding that, or before understanding the different laws of thermodynamics, we should be familiar with some terms regarding thermodynamics. So what are those terms? First is heat. Heat is nothing but the quantity of energy. Heat is energy. Heat is supplied in the form of energy, right? Heat is denoted by small letter Q. Heat, and its unit is joule or calorie. Can be joule or calorie, and 1 calorie is 4.2 joules. This fact also you can keep in mind. Regarding calculations, it might be useful. Okay, so heat we have discussed. Another is work. Work done. This you are well familiar in physics. Work done means what? It is a change in kinetic energy of a particular body that we know. So work done is nothing but, in thermodynamics, it is simply the product of pressure into volume. Pressure into change in volume. How can we say it is pressure into change in volume? We know that work done is force into displacement, F into x. So I can write it as Fx also. It's okay. Fx. What is force? Force is actually how force and pressure are related. Pressure is equal to force per unit area, right? So I can write force equal to pressure into area. So it is actually pressure into area into distance. What is area into distance? Area into distance is a volume. If there is a change in work done, then W equal to pressure into the change in volume. Pressure into change in volume gives you the work done. How much work you are doing to that system. And its unit is also joule, calorie, anything you can mention. Work done generally in SI unit it is joule. And calorie is not SI unit, but it's other unit of heat and work done, etc. Okay, work done. These terms you should be familiar. Another term which you have to remember is known as enthalpy. Enthalpy. What is enthalpy? Enthalpy is nothing but heat change at constant pressure. So enthalpy is defined as the heat change. Heat change. Heat change means a change in the value of Q at constant pressure. Constant pressure. This is known as enthalpy. It is denoted by the letter delta H. Change in enthalpy. Enthalpy is denoted by the letter H. So delta H indicates the change in enthalpy of a particular substance. New words, okay? Then this term we are familiar. Now internal energy. Internal energy. Internal energy. What is the meaning of internal energy? Internal energy is denoted by the letter delta U, or the change in internal energy. U indicating internal energy. It is a total amount of energy content of a system. This is the total energy content of a system. So how can you define internal energy? The sum of all the energies, be it rotational, kinetic, thermal, all the energies, all the possible atomic energy or different types of energies are present. Oscillatory motion, all the motion contain a particular amount of energy. So sum of all the energies in the particular system is known as the internal energy. So internal energy is the total amount of energy in a system. Okay, that we are familiar. Okay, now these terms are important, and using these terms we can define various values or things or capacities, different things we can discuss. Okay, so laws of thermodynamics. To understand the laws of thermodynamics, we are moving to the first law, zeroth law of thermodynamics. Thermodynamics, there is a law known as zeroth law of thermodynamics, or the law number 0. That's the important law, that's the basic law regarding thermodynamics. Zeroth law of thermodynamics is important. What is the zeroth law? Law of thermodynamics, zeroth law or zeroth law of thermodynamics. It states that, I will tell you what is the meaning, but statement is important first. It states that if two systems are in thermal equilibrium with a third system, if two systems are in thermal equilibrium, if two systems are in thermal equilibrium with third system, then what will happen? The two systems will be thermal equilibrium with each other. Then they will be in thermal equilibrium with each other. The statement may look confusing, but the law is very simple. How can you explain this law? The law can be explained by giving you an example. Imagine there are two systems thermal equilibrium with each other with a third system. There are three systems. System number A, system B, and there is another system, that is system C. Three systems, and they are in thermal equilibrium. How they are in thermal equilibrium? Two systems are in thermal equilibrium with third system. Thermal equilibrium, nothing, it means same temperature. Imagine like that. Thermal equilibrium means they are having the same quantity of heat. So imagine they are in the same temperature. So let's imagine system A and system B, they are individually in equilibrium with system C. That is, system A and C have the same temperature. Imagine it is 27 degrees Celsius room temperature. Imagine system A and system C are both in thermal equilibrium. Equilibrium means what? Here they are having the same value. Same equilibrium. That means they are having the same thermal value, or thermal value means the heat value. So 27 degrees Celsius is the temperature A and temperature of C also. So we can say system A and C are in thermal equilibrium with each other, and B and C also in thermal equilibrium with each other. That is, B also has thermal equilibrium with each other. This also becomes 27 degrees Celsius. So what is the meaning of the statement? Two systems are in thermal equilibrium with the third system. Then what you can say about the two systems? They are also in thermal equilibrium. That is, system A is in thermal equilibrium with C and system B is also in thermal equilibrium with C. Then we can say that system A also become thermal equilibrium, or it's also having thermal equilibrium with system B. This value or this connection between the systems is known as zeroth law of the thermodynamics. So this also has 27 degrees Celsius. Understood, right? If A equal to C, B equal to C, then obviously A equal to B. This is nothing but zeroth law of thermodynamics. Now, I hope this was very easy. Now we will move to the first law of thermodynamics, that is very important. To understand the first law of thermodynamics, you have to understand some more terms. Okay, so I will explain to you what is that. We are going to discuss about the first law of thermodynamics. Be it physical thermodynamics or chemical thermodynamics, the laws of thermodynamics are universal. Okay, laws of thermodynamics first law. To understand that, you need some new terms. The new terms are system and surrounding. What is the meaning of system and surrounding? System and surrounding. What's the difference between them? What are these terms? Imagine you are conducting a heat experiment related with heat. So imagine experiment related with heat, what it can be. Imagine I am going to measure the temperature of boiling water using a thermometer. This is boiling water. Imagine water is boiling, 100 degrees Celsius water is boiling, and I am going to measure that temperature using a thermometer. And this is an experiment. So here I am placing a thermometer. Imagine this is a thermometer. Okay? Thermometer. Imagine this is a thermometer and I am doing this experiment. My aim is to measure the temperature of the boiling water. This entire experiment I am conducting. That is my system. What experiment I am conducting or what apparatus I am using, that apparatus is known as my system. So this entire apparatus setup is known as my system. Now, whatever is there in this universe except your experimental apparatus, that is except your system, is known as the surrounding. So whatever is there in this universe except this system is known as surrounding. Be it your room, your classmates, or anybody, be it the other people in other countries or even the planets, everything is your surrounding. So it's just your system here, and everything except the system is your surrounding. So I can write that system plus surrounding. System plus surrounding gives you what? Universe. Equal to universe. System plus surrounding is equal to universe. So this relation you should remember. Now you have an idea what is system and surrounding. System is nothing but it is the experimental apparatus or experimental setup we are using for conducting an experiment on thermodynamics. And surrounding is the entire universe excluding the system. This is the basic idea. Okay. Now we are ready to move to first law of thermodynamics. You have the capability to understand the first law of thermodynamics after getting these keywords. Okay. One more thing I need to tell you about system. System, one more point I want to tell you, that is, system is of three types. System is of three types. What are they? The three types of system are, they are classified into three categories. They are open system, closed system, isolated system. Isolated system. What are the meaning or what are these terms? Open system. To understand these three terms in simple language, I would like to explain you an experiment of boiling tea. Imagine I am having tea kept in a glass. Imagine this is a steel glass having hot tea. This is hot tea. Is kept in a steel glass. This is your steel glass. When hot tea is kept in steel glass, open system means I am leaving the container open. That means what happens? After 1 or 2 hours, when you come back and see, you can see that the quantity of heat, initially the temperature of the tea, imagine it is around 75 degrees Celsius. Imagine the temperature of the tea is around 75 degrees Celsius. Imagine initially, okay? 75 degrees Celsius was the initial temperature of the tea, but after coming or after 2 hours, when I see or when I measure it, I can understand that the temperature became around 28 degrees Celsius. What is the meaning of it? The heat has lost from it. That is, the change in heat or delta Q. Delta Q means the change in heat. Final heat minus initial heat. The change in heat is not equal to 0. That means heat has exchanged or heat has lost from the system. So there is transfer of heat from the system. So I can say that it is delta Q equal to not equal to 0. Right? If now I have to talk about the matter. Matter means the quantity of the substance inside that. That was your T. How much T was there inside? Imagine 100 gram of T was there initially. But after I come back, after 2 hours when I see, only 99 gram of heat is, T is left. Why? Because the tea was very hot and some of the tea has evaporated, or some of the water content from the tea has evaporated. So there is loss of mass. Mass in the form of water has changed into water vapor. So there is change in mass. So the delta M or the change in mass exists. So I can say change in mass is not equal to 0. That means mass change has taken place. Such type of system in which both heat and mass change, or delta Q and delta M are not equal to 0, such system is known as open system. Then what is closed system? Closed system is nothing but the same apparatus, I am closing it. Steel glass I am having, imagine this is the same thing. The tea, hot tea, keeping with lid closed. I am keeping a lid so that nothing escapes from it. A lid I am placing on the surface of it. Surface of the glass I am placing a lid. And this is steel glass. Steel glass means what? Heat will obviously change because steel is a good conductor of heat, right? So temperature will reduce because steel can conduct heat. So obviously what happens? The tea will become cold after 2-3 hours. So I can say that the quantity of heat change is not equal to 0. Same way, heat has changed. But what about the quantity of the tea inside? The quantity of tea inside will not change because evaporation cannot cause change in mass here because it is covered. Whatever evaporate will obviously condense and fall inside that beaker or tumbler, anything. Okay, so water will not escape. So I can say that the change in mass equal to 0. There is no change in mass. So such system in which delta Q not equal to 0 and delta M equal to 0, such system is known as closed system. And what is isolated system? Isolated system is such a case in which, imagine the same tea I am keeping in thermos flask or vacuum flask. I am placing in vacuum flask or thermos flask. So if I am placing the tea in vacuum flask, this is the, imagine it's a vacuum flask which is sealed, and I am placing the tea inside it so that temperature will not change, that is heat cannot escape and matter cannot escape. That means both are constant in it. That type of system is known as isolated. Everything is isolated, means protected inside. Okay, that's a simple meaning. So I can write the change in the heat delta Q is equal to 0. There is no change in heat and there is no change in mass also. Such system is known as isolated system. Right? Now system 3 types we discussed. Now after understanding all these things, we can define the first law of thermodynamics. We are going to define the first law of thermodynamics now. What is the first law of thermodynamics? Let's write the statement first. The first law of thermodynamics says that the total internal energy, the total internal energy of an isolated system is constant. What is the meaning? The statement says that the total internal energy of an isolated system is constant. How can we define it? Total internal energy. Internal energy means the total amount of energy present in it. Of an isolated system. Isolated system means what? There is no change in heat. There is no change in matter. Then energy will be constant. If there is no change of heat or no change of matter or nothing is changing, then energy will not change. So energy will remain constant. That's the simple meaning of it. But mathematically also we have to explain. The mathematical explanation regarding it is the total internal energy is U. U is the internal energy. So change in internal energy delta U. Delta U, change in internal energy. The change in internal energy is 0. That means there is no change in internal energy. That means internal energy is constant. We know internal energy is the sum of the heat and work. This you have to remember. Delta U equal to Q plus W. This statement is very important, or this expression is very important. Delta U equal to Q plus W. That is, the internal energy of a system is the sum of the heat supplied to it or heat given out by it plus the work done on it or work done by it. No need to worry. Internal energy is the sum of heat plus work. Work means energy. Heat also means the amount of heat energy. Okay. We know that W, work done. Work done is actually pressure into change in volume. If volume final is less than the volume initial, if volume final is less than volume initial, then delta V equal to volume final minus volume initial. That will give a negative value because volume final is small value and volume initial is big value. So it will give a negative value. So in order to compensate that negative value, I am putting a sign convention here. Delta U equal, the work done equal to negative of P into delta V. So how I can write this expression? Delta U equal to negative, that is Q minus P delta V. This expression is very important. So this is explanation of first law of thermodynamics. So I hope you understood regarding all these things of first law of thermodynamics. In the upcoming videos, I will be explaining you the other topics related to thermodynamics. So watch that and please do like, share and subscribe. Thank you.